Using triangle similarity, we want to be able to identify the sides and angles that can be used to prove triangle similarity using the side and side angle side similarity theorems. We want to be able to complete the steps to prove triangle similarity using the side and side angles side similarity theorems. So side angle side. Now we have to remember when we're dealing with similarity, dilations is going to be very important because similarity isn't congruent. Doesn't mean it's the exact same. It means that in this case, the corresponding angles are congruent, but the corresponding side lengths are going to be proportional. So that's why we have similarity and dilation, because they're proportional. So as they dilate, they will enlarge or reduce, but these side lengths will remain proportional, and we'll do some examples there. And of course, that scale factor is the amount that they reduce or enlarge when it comes to that dilation. So as we look here, similar triangles, they have corresponding angles are congruent. So in this case, if these two, triangle ABC is similar to triangle DEF, well, corresponding angles. So angle A corresponds to angle D. Now those angles would be congruent. So they would be congruent. Angle B would be congruent to angle E. And then angle C would be congruent to angle F. So if they're congruent, they maintain the similarity rules, and then the side lengths are in proportion, okay? The side length proportion might be if AB is a side length of 1 unit, then the side length of DE could be 2 units. And then if the side length of BC is 2 units, the side length of EF could be 4 units. And what we start to see here is the corresponding sides are going to be double right here. Right? We're increasing by a scale factor, enlarging by a scale factor of 2. But again, we'll do some examples there just to know that our angles remain congruent, and then our corresponding side lengths will be proportional. So using the side similarity, and what we want to consider here is that if the corresponding side lengths of two triangles are proportional, then those triangles will be similar. So a proportion, a fraction, a ratio. So let's get an example here. Okay, so we have two triangles, and I'm telling you that triangle ABC is going to be similar to triangle DEF. And what that means is, well, DE is going to be the ratio of DE is going over AB is going to equal the ratio of EF over BC, and that is going to equal FD over CA. What that means is they're telling me that these side lengths are going to be equal proportions. So if I apply some values to this, what I should be able to say is the proportion of DE over AB. So we know that DE is going to be 6, right? DE is 6 over AB, and AB is 4. So when I look at that, all right, I had to fix some identifications there. So let's redo that here. So we have DE is proportional to AB, and then we have EF, the ratio of EF over AC, and then we have the ratio of FD over BC. So all of those, let's calculate those here. So if I have FD over BC is going to be 12 over 8, which is going to be equal to 3 over 2. And then I'm going to have EF over AC, so that is going to be 9 over 6, or that is also going to be 3 over 2. And then DE over BA, or AB, which is going to be 6 over 4, which is going to be 3 over 2. So in doing that, it looks like we should be able to prove that these triangles are similar based on that their proportions of their sides are all equal, right? If the corresponding side lengths of two triangles are proportional, then the triangles are going to be similar. And in this case, all three sides are proportional, the same proportion of 3 over 2. So yes, we can say that that is the case, that they are similar triangles. And we can use this same information to find missing links. However, before we do that, we can go back here and say that if these side lengths are proportional, then they are going to be similar triangles. And if they're similar triangles, then we know that the angles will be congruent. So angle 1 is going to be congruent with, angle D is going to be congruent to angle A. Angle E is going to be congruent to angle B. And then angle F and C will be congruent. So there we go. That's one of those things that we can go back and identify. Okay, so looking at this example here, what value of x will make the triangles similar by the side-side-side similarity theorem? Okay, so we have two triangles here, and of course not drawn to scale, but it looks like I have two sides that are going to be equal, which is a 15 side length of 15, and then the third length will be 21. Now, I should be able to recognize that that's an isosceles triangle, right? My two side lengths are the same, and then I have a base side. And then so over here, I have the same thing. I have two sides that are going to be equal and then a base. Well, if they are side-side-side similarity, or to prove that, well, they all have to have the same proportion sides. Well, in that case, these sides would be corresponding, these sides would be corresponding, and these sides would be corresponding. Well, so in that case, the ratio of 20 over 15 is equal to 4/3. Well, in that case, I need to have the ratio of this third side right here be 3/4. Did I just say 2/3 a minute ago? I meant 3/4 if I did. So in that case, I would look at x over 21 needs to equal 4/3 in order for it to be a similar triangle, for that side to be in proportion to the other sides. And in doing so, you can cross multiply. And you would find out then that 3x is going to be equal to 84. Divide both sides by 3. And then you have x is going to be equal to 28, I believe, 28. And so if x is equal to 28, then that tells me that if x equals 28, then these would be similar triangles based on the side-side-side similarity theorem, because they are all in proportion, the same proportion of 4/3. So there you go. I'm able to find that missing side. Or I'm able to find the missing value of x and then plug it back in and find out what the side length would be for it to be similar. Now for side angle side similarity theorems, if an angle of one triangle is congruent to an angle of a second triangle, and the side lengths, or the lengths of the sides including these angles, are proportional, then those triangles are going to be similar. So what the heck are they talking about? Okay, I have this, and it's telling me that if I have a congruent angle, and then my side lengths are going to be in proportion, So I have over here A, and then I have 2A, and over here I have B, and I have 2B. Well, it looks like my proportions may be the same. In reference to corresponding sides, let's just look at it that way, that if this side corresponds to this side corresponds to this side, well, it looks like as I go from triangle number 1 to triangle number 2, well, I'm going to have 2A over A, which is going to be 2 over 1, or I can have 2B over B, which is going to be 2 over 1. So it looks like I have my two sides are going to be proportional to each other, and then I have a congruent triangle. Therefore, I'm going to have the side angle side similarity theorem is going to apply here. But think about it. If this length is proportional to this length, this angle is the same, then that means right here, right, this angle is going to be the same. I'm sorry, maybe not that quickly. This length is proportional to this length, and this length is proportional to this length. Then yeah, it looks like this side is going to end up being proportional to this side. So now if all three sides are going to be similar, then sure enough, we know that we would have congruency or similarity that way also. So just being able to look at some of this information and think about what it's telling me, and then using it and practicing with it. Okay, so the ratios of these two corresponding triangles are equal. The ratios of the corresponding sides in two triangles are equal. And then what other information is needed to prove that triangle FGE is similar to triangle IJH by side angle side? Well, they're telling me that the corresponding sides of these two triangles are equal. Well, how did they make that determination? Well, they're saying that this side corresponds to this side, and this side corresponds to this side, and if I were to look at that, I would have 30 over 20, which is going to be 3 halves, or I would have 15 over 10, which is going to be 3 halves. So there I have two sides that are proportional, and now I need to have, in order to use side angle side, well, I would have to have an included angle would have to be congruent in order to use side angle side, because there I would have side similarity, angle side similarity. So that would tell me that angle I and angle F would have to be congruent to angle F in order for it to fall under the similarity rules of side angle side. So just being able to garner these few little nuggets of information and be able to work them out. And so again, we want to be able to work with identifying the sides and angles that can be used to prove triangle similarity using side, 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 and side angle side. And then complete those steps to prove triangle similarity using side, 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 and side angle side. So I guess we can probably do one more problem here, but just remember that side similarity theorem states that if all the corresponding sides of the two triangles are in proportion to each other, then the triangles are similar. Then you can also have side angle side, where if a pair of corresponding angles of two triangles are congruent, then the included sides of those angles are in proportion to each other. So, but let's go ahead and knock one more example out here. And what I want to do is I want to work with the coordinate plane. All right, so we want to be able to prove that these triangles are similar. And what we've been working with now, in order to prove that triangles are similar, we've needed to have, well, at least two sides that were going to be in proportion. So what we can do is let's just look and say, hey, I'm betting this side and this side are corresponding, and then I'm betting this side and this side are corresponding. So let's see, if I were to look at the lengths of XY, it should be 4, and then BC should be 8, And then if I look at ZY, that should be 3, and then AB should be 6. So it looks like I have a proportion of BA over YZ, which is going to be equal to 6 over 3, which is 2 over 1. And then I also have BC is going to be in proportion or corresponding to XY, which is going to be 8 over 4 or 2 over 1. So it looks like my scale factor is going to be 2. So it has been enlarged or, reduced, depending. But as I go from this triangle to this triangle, we are enlarging by a factor of 2. And then I should be able to figure out using, let's see here, AC should be in proportion to ZX. And how are we going to do that? Well, that's the hypotenuse, so it may not be as easy to work out. But what we can do is use the distance formula to figure out the lengths of those hypotenuse. Okay, so if I use the distance formula to find the distance of the lengths of my hypotenuse, remembering that the distance formula is going to be x2 minus x1 squared plus y2 minus y1 squared. Okay, and then solving that, it turns out that when I do my substitutions here, that the length of AC proportionally to ZX is going to be 2 over 1, which was the same. Now we also know, looking at this, that these two triangles are right triangles, so that's useful information. Because now I have, if you think about it, I have an angle, and I also have, I was looking at this, and I could say that I have side angle side similarity, or I could say that now that I found that the third length is the same proportion, I could say that I have side similarity. So it just depends on what we're looking for there. If I have side similarity, well, I should know then that I should be able to recall then that angle A is going to be corresponding to angle Z, and they would be congruent. And then angle C is going to correspond to angle X, and they are going to be congruent. So that's just some of the stuff we can look at and prove. I was able to prove it 2 different ways that it was going to be similar. So there you have it, using side, and side angle, side triangle similarities.